Here is Eckhart in Hong Kong. This is a tutorial how to make a tool for a tool mount for a robotic arm. In this case, it is the robotic arm of an ABB IRB 2600, which we have at our lab. And but this is a tutorial that generally is useful if you want to build something that fits onto something else. And Rhino is quite good for that. This is a tutorial that features both a Rhino application, but then we also move into working with Grasshopper. So this is the entire tool. So if we look at this in more close detail, so we have down here is the tool mount. So this is what we actually have at the robot, right? We have, it sits in this direction on the robot. We have 4 holes where we can actually bolt something on. This is the plate that goes onto the flange on the robot, right? So we've got, this is basically what we have. On the bottom here is the robotic arm. This is the tool mount. And on this tool mount, we usually put our tools on. So be it the wire cutter or the milling machine and all most of other tools, the tools we are building, we use this little extension arm, which is, was specifically made for this robotic arm. It's a useful thing to have, gives you a little bit more range and distance. So we have, when you look closer in, we have this little up stand here, and some tool plates have that you kind of know where is up. The up is up there actually. So what have I designed? Let's click out of that. I have designed a little up stand that we can bolt onto this, and if you look at the underside, so we have these little indentations where it kind of clicks into a certain position. And on the top, I have made a little slot. So perhaps we can also cut a little hole in here where we can then put a metallic thread into it, and we put a bolt in to affix whatever we can actually cut with a laser cutter. So this tool can be printed, so you can export this as an STL, send it to a 3D printer, and you can print it. But I actually want this exchangeable for simple tools that we can actually quickly laser cut on the laser cutter. So what have I done here? This is a little bubble blower, which I have alluded to in one of my tutorials, and this is entirely made in Grasshopper, and so I will probably make some changes on this, but I will probably just 3D print a lot. But so you have always this option, but this is just for demonstration purposes. So on the bottom we have this plate entirely produced in the Rhino environment. This is actually designed also in Rhino in combination with Grasshopper, and the top entirely in Grasshopper. So let's have a look at the Grasshopper file. So, and I will go with you through this tutorial. So this is actually up here. This makes the upper part of the bubble blower. It's quite a simple thing to do. What I will give you, let's just blend everything out. What you will receive from me is this tool mount. So we need to activate this. And so we've got a B-rep. And hold on, let's put this here. And perhaps we're gonna go to wireframe mode. No, it doesn't show it then, huh? Oh, I need to show this here. So this is the B-rep, right? And a B-rep is a three-dimensional container that contains data. So here, this tool mount. So this is the B-rep, which I imported via right-click, set multiple B-reps. So when you design something in the Rhino environment, you can bring it into the Grasshopper environment by importing it as a single B-rep or multiple B-reps, and then it's parameterized. So we have the data here of this. I think, oh yeah, of course it does exist as a file in Rhino. You've got this node, which is a deconstruct B-rep, and that shows you what this actually contains. It contains the faces, the edges, and the vertices. So if we blend this out, I actually have done this here. So this shows again what you have seen before, but it basically shows you the surfaces without the edges. If we activate the edges, come on, and blend this out. Yeah. Oh, is there some data missing? Oh no, this is perhaps just the file. This should really show. So, so this just shows you the edges. You see this little line. This is actually, come on, why are these previews not working? I have made a little chamfer here to kind of make it look nicer. So this double line is just a chamfer. Yeah, it's basically running a sandpaper along, an edge to make it a little bit smoother. Why are these previews not showing? Very weird. You also have points data. Is it showing? Oh yeah, we have the points. This is where the cylinder starts, and so on and so forth. Right. What you will get from me is just this file, or perhaps just the B-rep, right? Come on. So, and I blend this one out. Okay, I want to do the entire tutorial completely from scratch. So what you will get is this B-rep here that contains the bottom part here. So if I switch this on, I select everything, I switch this part on, and then you see the parts. But what I'm going to do is I start in my Rhino environment with a new file. Okay. And here we have it. So perhaps we quickly go to the perspective mode. So here we've got our tool. I have set the tool head in such a way that this top surface sits at the XY0 plane, and that these little upstands here kind of protrude out from the zero plane. Okay, so what we have to do right now is at the moment, this is parametric, so I can't click on it, I can't work on it. So I right click and bake it. And I put it in the first layer, press OK. And now I can actually click on it, so on these poly surfaces. What I'm going to do with the Grasshopper, I switch this off and put it away for now. I drag this to my second screen, but now we are concentrating on this one. We go to our 4 views and we shade it. We shade this as well. Okay, so it's quite good to name your views. So this is tool mount. And here you can lock layers on and off, or you can visualize them on and off, which is a very useful thing to do. So what I want to do is I want to just extrude basically I want to make a tool mount that sits here, so a tool base. So you want to create a tool that sits on a plate, and that this plate's gonna clicks onto these upstands here, and we can bolt it on with these 4 screws. So how are we gonna do this? If I click onto this, I think, what's this one? Oh, that's just the chamfer. Can I click onto this? So this is the polygon. I think I need to explode this to take it into all its parts exactly. So I have just clicked onto the polygon here, and I used this one, explode, and now I can select the individual parts, and you can now see that I can select just the top bit here, but I want to extrude this. So you should have a little round ball. You can click onto this, and I want to extrude it into 10 millimeter. Now I do not want to do this in this layer, and I'm working on the default layer. I want to work on this one to give it a different color. So if you click on the color here, you get color option. Let's go more like into the lavender. Okay, so I work here now. Okay, so various ways to, if I hold onto this, you drag on this round ball here, you extrude it like that, but then you have very little control on the measurements. You can click onto it, and then you can type in the millimeter number, like 10. What you can also go, you can type into your command line, you click on your surface, then you go extrude surface, this one, and then you can type in a number. You want to have it solid, that's a good option. And I want to go, let's do 10 millimeter. Okay, so we now got a solid extension in our second layer, which we call tool. So now all I need to do is, as if I go to my tool mount, I need to take these 2 upstands off, right? So we do this with a Boolean function. They can be, make sure this is solid. And sometimes they don't work, or but let's try difference. So select surface of polysurface to subtract from. I want to subtract from this one. I press enter, and you want to perhaps hide this. Select surface of polysurfaces to subtract with. I want to subtract with this. Press enter. So let's see what we're going to have. I'm going to go there and I hide this. So that didn't work. Let's try solid difference Boolean split. Let's try this one. Surface to subtract from. Enter. Select the cutting surfaces. It might be because I switched things off. It might have been you need to kind of see both. So let's switch this off. Yes, we have this. I think I unclicked the basic. What we have is also a copy of these bits. So you just need to click onto these ones and delete them. So now you can see we have these indentations into our ground plate. So that's pretty much all we need to do here. Very nice. Okay, so we've got our tool mount, our tool plate. The tool mount we can switch off because we want to concentrate now working on this one. Here I would probably go to our 4 views, and I want to create a little upstand. So basically what I want to do is I want to create a tool we can put on the tool mount, and I want you to create something that you can cut quickly with a laser cutter, right? And in this instance, we will do a bubble blower, which I alluded to last week as a stupid idea, but you know, this is just an exercise, but it's also an exercise where you show how Grasshopper and Rhino environment works really well together. So continue on this one. Here I just going to use a box. I use the box center corner height. So do we get this? Yeah. And center corner 15. No, length to 30. That looks good. And width 20. Okay. Enter and the height. You can basically now move from all these windows to windows. This is what I actually like. Let's do it also 40 mil. Okay. And we have started this, as you can see, from the ground plane. So it's not necessary. I want to lift this. You go to your box edit and you can sort of see Z minimum is 0, but we've got our 10 millimeter plate, so we lift this for 10 millimeter. And obviously I didn't really hit that center point because my snaps were probably off. Yeah, center was not clicked on. Doesn't really matter. You could just type in, make sure that here you have these options where your objects needs to be aligned to. So we should have this now nicely aligned in the center. And then obviously you can go fancy schmancy and to make it look nicer, for example, we can chamfer or fit it. So this is a round edge or chamfer surface. And here, just to show you, we can select our chamfer. You can also then, I think this is a millimeter, you can change this. I want to do this on all 4 sides, and you just basically just press enter and it deletes. It repeats the previous code, so I just press enter. Hold on. A repeat chamfer surface here and here. And annoyingly, we have these little overlaps. You can do this and delete them with the function trim. So I use my cutting object, I use this, and then I should be able, hold on, I cancel this. Again, I want to trim this, select cutting objects, this, press enter, select objects to trim, it's this one, and we've got this on this corner as well. We do this on the other side as well. So, and we do right click, trim. If you work on a PC, you might have to set it up in your preferences, but you can also set up that you have like the last 10 commands you have, because very often you do things repetitively. With a PC, it's usually you press the middle mouse wheel where you get the contextual menu to select your previous 10 codes. If you just want to repeat the last thing, you just press enter, the last code you use, so you just press enter. Anyway, so I select my cutting objects, it's this one, I press enter, and I then delete this one, and I delete this over. This is not the cutting object, cancel. So I want to trim this. This is my cutting surface. Press enter and I delete this corner. So this is looking good. Press done. So we've got this little upstand. And now I again, basically what I want to do is I want to insert, we have 3 millimeter acrylic at the campus, and there we basically, I want to kind of create a slot where we can insert a piece that is 10 millimeters wide or 15 millimeters wide. I need to see how it turns out, but 3 millimeters deep, right? Here in the center part. And here we can perhaps just put a hole in where we can put a metal socket with a screw to fix it, right? So, it's sometimes quite good to just kind of sketch this up on a piece of paper, how you actually think this should look like, and then the rest you can do in Rhino, and then subsequently Grasshopper. Again, we go to our view from the top, and I should have in my right-click menu box center corner height. Here view source in the center, and I go to 20. No, we want to do 10. A 10 millimeter slot. Yeah, let's do a 10 millimeter slot, and the width is 3. Okay, done. And extrusion. So I move to my down. So the extrusion probably 20. Here you can see it's quite useful to have an extended keyboard, and so it's useful to type in to know the sizes you're working with, and you just type in the numbers, right? So I've got my extrusion sitting down there. So I select this one, and I go, again, it didn't really hit the center too well, 0, 0 to 20, apply. Now let's drag this up here. Okay, and now I want to cut this out. Again, I go, what did work? Pull in split, select surface to split. It's this one. Press enter and select this one, press enter. I should delete this. Delete, and we have our slot here, right? Okay, so we can insert something here. So, and that's pretty much all you have to do in the Rhino environment, right? Nice and sweet. Okay, if we go back to our layers, so we've got our tool mount, and you've got a tool connector. If you have something like this, you can then just use this to laser cut all sorts of things in here. You can make variations where you perhaps make a little round hole to insert a pencil. Make this then a little bit longer. But so this is kind of we can easily print this at Kai-Tak with the 3D printers for sort of simple applications, simple tools. So really not much to it. Obviously, what you do then is you in the Rhino environment, you would export this. So you go export, press enter, select objects you want to export. I highlight what I want to export. I right click, and now obviously you would export it as because we use a 3D printer as an STL, a stereolithograph, and you can send this straight to your 3D printer. Okay, I'm not going to do that, but I guess you all know this. You should really all know this by now, or coming into this. So it's an STL, and OBJ works as well. Where are we? Our OBJs are here, right? So STL or OBJs. But I will just stick with the stereolithographs, because this is sort of the democratic basic what we have when we want to 3D print things. Okay, that's all there is for the Rhino environment, and then now we move into making a bubble blower and to get the file ready for the 3D for the laser cutting, right?